Hello, uh, good afternoon, everyone. Dear authors and invited guests, welcome to the technical session 4B. My name is Anisha, and I am the moderator for today's session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2023, Ahmedabad, India. The seventh edition of the conference is being organized in a hybrid mode. The physical event was held in Ahmedabad, India on 27th of April 2023, and the virtual event is being held through Zoom today, that is 28th April 2023. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. And on 7 minutes, I will raise a gentle reminder. And there is another request to all the participants that you all please stay connected with us till the closing of the session. And now, before starting the session, I would like to introduce you all to the chair of the session, Professor Meenakshi Memoria ma'am. She has 17 plus years of teaching experience in different academic institutes. Presently, she is in Uttaranchal University as an associate professor, and her research and teaching interests include machine learning, grid computing, theory of computation, compiler design, operating system, intelligent system, data structure, etc. She is an IEEE senior member and an executive committee member of IEEE UP section since last few years. And currently, she is the chair of subsection Uttarakhand Coordination, Outreach and Strategic Planning under IEEE UP section. So I welcome you to the session, ma'am.
Thank you.
Okay, so now we are moving forward to start the session. And I would like to invite our first presenter. Rishikesh K. Haridas to present his paper with the title, A Novel Privacy-Centric Training Routine for Maintaining Accuracy in Traditional Machine Learning Systems. So, dear presenter, you may please start with your presentation.
Absolutely. Good afternoon. Thank you. Let me just screen share this. This paper is a novel privacy-centric training routine for maintaining accuracy in traditional machine learning systems. The machine learning is the art of deriving insights from data. We have a naive model which goes in with some data and is trained. A trained model can make reliable predictions, and this is the common workflow of machine learning. Data is commonly sourced through various means, be it open sources on Kaggle, or those interested, like large corporations, in maintaining commercial models. They do so by doing data collection surveys, specifically catering towards their model. This leads to a major problem. We cannot work in privacy-centric domain. We cannot work in data-sensitive domains, such as healthcare, finance, and other domains where user data is of paramount importance, and we cannot afford any leaks. Users simply abstain from sending their data to the cloud and to corporations whom they do not trust. Needless to say, the problem with data scarcity: without enough data, machine learning algorithms may struggle to identify meaningful patterns, which may also lead to overfitting, where it does not generalize to all data, and this may also lead to biased models that do not accurately represent the real world population. Firstly, we'll cover some existing workarounds, the lacuna in existing workarounds, and how our systems solve the existing lacunas. Firstly, we have federated learning proposed by Google Research. Federated learning is where models train on several users' device, then model averaging is performed on each of these models to develop a general model for all systems. The problem with federated learning is it simply compresses several models into one. In doing so, it may lose out on some subtleties and therefore compromising accuracy on the whole. Secondly, we have the on-device AI approach, wherein we have power-hungry chips, which may not perform very well on all kind of neural network tasks. We can see here that big players like Apple developed special neural engines on their A13 Bionic chips to ensure process a proper on-device AI approach. This is how power hungry it is. Our proposed solution is to hold the data and transfer the model repeatedly. Our approach involves having a naive model and sending that onto a user number one. On user number one's device, this data trains locally, thereby gaining information and experience from user number one's data. Now, the model is sent back to the server and is now slightly trained. An important point to note here is that only the model is sent back and there is no data breach of any sort, hence maintaining the wall of privacy. The slightly trained model is forwarded to user number two, where it trains locally on user two's data and the model is sent back. This process repeats back and forth for n users. Thus, the model is exposed to million users worth of data, thus achieving accuracy akin to traditional systems without compromising on data privacy, allowing us to work in sensitive domains. This is a pictorial representation of our approach, wherein we can see how the accuracy increases as we communicate with new devices. Here we have the cloud where the model is stored and is sent to a particular user's phone. The user, after training on this data, sends back. This repeats for multiple users. User number two, the model is sent back, three, the model is sent back, and so on. In doing so, it exposes itself to a lot of information and thus is able to achieve very high accuracy. Thus, this system retains 100% accuracy as it would in the case of we actually taking the user's data and training it on all the data stored, while it also maintains 100% machine learning accuracy without allowing us to work in any data sensitive domain. Of course, applications of this is limitless, be it health data, which is extremely sensitive, be it location-based data, be it some kind of familial issues, some kind of commercial banking applications, financial applications, anything which is data sensitive. This is a modern workflow for them all. Currently, we have realized the proof of concept using health data, where we use this system for sleep apnea detection. Sleep apnea is a respiratory disease wherein users may experience blockages in breathing, and we are using this system to train on their health data, which they wouldn't upload otherwise, and have that working. This is a work in progress and is a proof of concept of this paper. That ends my presentation. Thank you.
Okay, thank you, Rishikesh, for the presentation.
All right, thank you.
And now we can move forward to our next presenter. And I would like to invite Rosemole Thomas to present her paper with the title, A Study on the Stock Market Trend Predictions. So, dear author, you may please start with your presentation now.
Hello.
Yes.
Good afternoon, all of you. I'll just share my presentation. Okay, my paper is a study on stock market trend predictions. And here are the authors. Myself, Rosemole Thomas. Here I'm a research scholar from Gujarat University, Ahmedabad. And other authors are Dr. Hiren Joshi, Dr. Hardik Joshi. They are the professors of Gujarat University, Ahmedabad. So the agenda would be like introduction, the literature review, the benefits of this research, the conclusion, and references and bibliography. So as an introduction to this paper, has maximum returns on investment is the desire of any investor. But due to the fear of the risk involved in the stock market, many of the investors do not invest because they feel that their hard-earned savings would be at least safe. So the problem here is the fear of risk here. So as we already know that the National Stock Exchange was incorporated in November 1992, and it has received the recognition for stock exchange. The stock market predictions is a very difficult and a complex process, especially when the accuracy of the prediction is concerned. The NSE, it is providing a platform in the form of day trading, which is most popular nowadays among the investors. And mainly my focus would be like Bank Nifty, which is a sectorial index with a focus on only on the banking stocks. And it mainly consists of maximum of 12 stocks of the bank. The various ways of predicting the stock movement is fundamental analysis and the technical analysis. The fundamental analysis, as we know, that it is a way of predicting using the company's future based on the financial reports of the business. Whereas technical analysis, it is predicting the future solely depending on the past trends of the market. As we know that it is said that the past iterate. So the patterns on the stock exchange also do. The data is mapped on the graph to analyze the several patterns here. Apart from this, we have this independent analysis of the stock exchange, which can be further combined with the technical study also to give a better results. So various news articles and events occurring throughout the world has its effect on the stock market as it is revolving around the psychology of the investor. Investor psychology are driven by various moods, and the natural language processing can be used for analyzing the news articles and various social sites to well understand the psychology. So here first we'll focus on the literature review based on some of the technical analysis. So here are few papers that I've been referred to. So the first one is based on the PRE model and deep neural network. So the combined model, that is a hybrid model of PRE and DNN, has given a better results. But we can improve this model with some of the candlestick pattern identification, which could be the future work of this paper. The second paper is stock market prediction using LSTM and RNN. So again, this model is capable of tracing the information, but the data length and the number of epochs needs to be changed so that the prediction accuracy can be further improved on. The next paper is predicting the stock market using machine learning and deep learning algorithms. And here two types of data is concerned, that is continuous and binary data. It is a comparative analysis page here. And here 9 machine learning algorithms and 2 deep learning methods have been used. And it has been found that the deep learning methods, that is RNN and LSTM, has been better in predicting the opening prices of both the types of data. The next paper, there is applicability of deep learning model for stock price forecasting. That is an empirical study of BankX data. So here 4 deep learning models have been used, and in this GRE proves to be giving a better results for especially directional accuracy and for shorter forecast. Whereas when it comes to longer forecast, is extreme learning machine model that has been comparatively better in many of the financial forecasters. The next paper was stock close price prediction model using machine learning method technique. So here we have used ANN and RF that was also implemented, but ANN, it has proved to be a better technique. But the future scope, as I told, that along with this deep learning model, the financial news articles, especially various financial, along with the financial parameters, needs to be concerned or need to be included so that the prediction accuracy can be improved on. The next paper, that is algorithmic financial trading with deep CNN, that was a time series to image conversion approach has been used, and it has also proved to be better. But an evolutionary algorithm, apart from this, can be improved for the performances. Now we have the next paper, that is NSE stock market prediction using deep neural learning model. So here 4 deep learning architectures have been used, and apart from that, a linear model, that is ARIMA model, has been also used. So CNN again here is outperforming the other models, but a hybrid network model can be explored for future work. The next one is stock price prediction using artificial neural network. So MLP neural network technique have been used, and it has given a satisfactory output with lesser error hierarchical deep neural network designed for stock return prediction, and it has been giving better result. That is, it has improved the prediction accuracy up to 71%, and it is reducing the learning time also for DNN. But we need to improve this. We need to focus on learning from the financial news, reports, and the moods. That has to be combined along with this so that the accuracy of the market can be further improved. The next paper is multitask learning based on least square support vector regression for stock forecast. So again, the hybrid model of that is an extension of that model, has given a better results. Again, we can apply deep learning technique along with this to improve the future work for us. The next paper is stock price analysis with natural language processing and machine learning. So here there are again some models, that is two traditional machine learning models and two deep learning models have been used. But again, GRU has the highest average accuracy prediction and precision also in this. But GRU and LSTM both are taking longer time to predict this based on the larger amount of data that they are having. Next one is stock market prediction on high frequency data using generative adversarial network. So again, LSTM, CNN, and GAN were used. So again, it is high frequency data using generative adversarial nets that was performed better. But we need to integrate this predictive model under multi-scale conditions. The next two papers, that is, the first one is predicting stock market index using fusion machine learning. So here two-stage approach was used. In this, the second stage approach where two algorithms have been combined, that is SVR-ANN, SVR-RF, SVR-SVR fusion prediction models were used. But the best performance was given by SVR-ANN model. But we can improve this model again using genetic algorithms, some more statistical parameters. As I told, the news factor can be involved, used in this, and the news can definitely be classified as the good news, very good news, bad news, and worse news. And a semi-supervised system would give a better prediction with more accuracy. The next paper is predicting stock and stock price index movement using trend deterministic data preparation and machine learning technique. Here, two approaches for input were used. And in this trend deterministic data approach has given much better result. But along with this, again, other macroeconomic factors, that is variables, has to be included. Then only we can improve the accuracy of this paper. Again, this paper is for short-term predictions, so long-term predictions must also be thought of in the same direction. So this is just a comparison of the papers that I've discussed already. So here are the algorithms that they have used, the results, the data sources that they have gone through, the matrices to check the accuracy of the algorithms, and these are the future scope of this paper that can be worked out on. Now the literature review based on the sentiment and analysis. So these are few papers which I have gone through for the sentiment and analysis. So the first paper in which the text analytics, hourly sentiment index building, and LSTM AI based model have been used. So again, LSTM along with the textual analytical model is far better compared to other models. But here the problem is the wastage of lot of useful information because of the stock market, stock exchange time period, the opening and closing time period, as when it is matched with the news information, the remaining news, which is of the other time, is being lost or is being wasted out. The next one is stock trend prediction using news sentiment and analysis. So again, this is a classification model. Okay, in that we are having the news articles which has been classified as positive and negative, and observations shows that RF and SVM perform well in this type of paper, and the accuracy of this prediction is more than 80%, and it is giving a better accuracy as compared to other papers. The stock market forecasting using NLP and natural language processing and LSTM. So again, in this we are incorporating the text pre-processing methods, and in this again LSTM has been used, and it is giving a better accuracy or good accuracy we can say, and a lower error rate. Next one is predicting the stock movement based on financial news with segmentation. So again, the most significant here in this is SVM and MKL is that the SVM can only use the data with single characteristics, whereas MKL can use various data at the same time, combining multiple kernels. The next one is the sentiment analysis of stock market using a novel dimensional balance arousal approach. So here it is a hierarchical title keyword based attention hybrid network. and has already said it is a hybrid way of giving it, and it is giving a better results. The next one is sentiment analysis for Indian stock prediction using Sensex and Nifty. So it was a future work. We can improve Python scripts can be used in this and for advanced function. So as I told, the benefit of my research would be, so far the technical analysis or have been used for predicting the stock price, which is not giving the accuracy that is needed by the investors for buying or selling of the stock. So the fundamental factors also needs to be considered for the for further research, and the research will generate more accurate results, which will help investors invest their savings. The research and analysis going on in this field for a long period, but the stock market is so versatile that the algorithms and techniques fail to give the accuracy that they needed by the investors. The parameters that is influencing the stock value needs to be analyzed more accurately, and more articles and other factors presented as news needs to be taken into consideration for the better prediction result, especially when where the companies are not having their own websites. We can even use the Twitter information to better predict the stock values. The hybrid model needs to be developed for more precision in the stock trend predictions. So these are the references and bibliography. And thank you everyone. Special thanks to the organizing committee for giving me an opportunity in this participating in the 7th International Conference of ICTIS 2020-22. Thank you. Any suggestions?
Actually, if I'm talking about your paper, the title is very simple, and the one thing is, actually you have done, I think the survey was very good, whatever in which way you have done. But the main thing is you have not done any implementation part.
Ma'am,
and the topic is very simple. I think a lot of work has been done on this topic.
Ma'am, it's my first paper. It's a review paper that I have done. The next paper would be my implementation paper. Hopefully, I would do it in the same conference.
But I think a lot of work has been done on this topic. I think you should have to choose. You should have to choose. You should have to take some another topic.
Okay, ma'am. Okay.
It's just my suggestion. It's up to you. You can choose another one. Just try to implement something on any idea so that it would give some results. You can apply some technical. You can apply some technical implementation.
Okay, ma'am. Thank you.
Okay, thank you. Next.
Thank you so much for the presentation. And moving forward to our next presenter, I would like to invite Mohammad Ashif M. to present his paper on the title AI-Powered Authentication for Smart Home Security, a Survey. So, dear author, you may please start with your presentation now.
Good evening, ma'am. Hello. Good evening, ma'am. Let me share my screen. Good evening, ma'am. Our project is an AI-powered authentication for smart home security. Our project members are Gopinath, Yadeswaran, and myself, Mohammad Asif. The main objective of this project is to deliver an authenticated smart door for an homemade products. Basically, it is an IoT project, but we carried out it with an software implementation. It is our proof the concept of smart door we have used in live camera on the front side setup. So where we can use the display monitors to watch the outsiders from inside the home. We can able to authenticate those trespassers, whether they are a known user or unknown users, with a trained model of our data. The main objective is to design the framework for smart home security using a computer vision systems and face detection technology. We used an CNN algorithm to get a better prediction model. Also used an Glassman field algorithm in this project. Let me introduce our project. The biometric is an unique for everyone. Everyone has their own facial recognition, iris, and then thumb, finger, etc. The aim is to research out the face in the database, which is the most similarity with the given face. As the result, there are new products available that can out convenience and security to any houses, but using an already predicted. As a result, there are a number of new products, but our project is different from the others. We can able to use an existed smart CCTV camera to implement this project. No need of additional IR scanner and others, etc. These are the related works that we go to this project to gain some knowledges and references. As we see the related gap works finding, let me tell you that currently we are facing a security issues in every aspect. Most important characteristics of any smart home security system discovers the people who enters or leave the houses. Yeah, you can say there are a number of possibilities to bypass this smart home security system, but there is always an real-time technologies we implemented in here. So nobody could able to bypass unless this has been hacked or something technical issues may arise. This is the proposed architecture of our project. First of all, uh, a new user have to be register their face and then biometric entities to the database. So whenever whenever a new user enters the house, the system automatically detects whether it is a new user or unknown user. With the help of an camera, we can able to capture the live actions, and these live actions can be reported immediately throughout the mail. Let me explain you through the process. Here, the software specification of operating system Windows. You can use an Linux and another Mac OS Catalina. The front end we have used is an Python, and the back end is an MySQL. The IDE can be used anything VS Code, Python, etc. The minimal hardware specification of this implementation of project is an code to duo processor Intel and 1 gig of RAM and then hard disk of 160 GB, and then it's just an basic computer that we have all our home. Let me tell you about the modules in the project. The framework construction. Yeah. The framework construction nowadays, technology is increasing. Facilities for human beings are increasing. The traditional doors, yeah, traditional doors has an key. Anyone with a key can easily pass through the door, and I don't suggest it has an good security process. But let me tell you, with an smart home security on our project, nobody can easily trespass into a house unless you are an owner or an registered face with the system. If they are not, they have been immediately reported to the owner of the admin or anyone else in the family members who have access to this network. The facial recognition. To register a face, we have to log into the our custom-made website where we can able to register the faces of family members and other members. So where we can able to use the biometric and the facial recognition. The facial features can be extracted through an CNN algorithm and then a Craftsman field algorithm. Mask detection. Of course, nowadays after an corona affected pandemic season, most of the people has started wearing a mask. So if a person with a mask can be also be notified how there is an 100% of the facial recognition. If the 50% of it has been blocked or not visible properly, it considered as an masked person. That's what's the mask detection modules in our project going to do. Facial classification. Face detection is done in this process. Yeah, as I told you before, CNN algorithm is used here because it has the better accuracy and uh, compared to all other algorithms, it has the better security and accuracy in all steps. The network that we have trained in three steps: initialization, face registration, and the knowledge transfer to face condition identification. The alert system. Of course, if an unknown user tries to trespass the door, it have been notified immediately to the admin through the SMS and then mail. Uh, so where we can able to protect ourselves from the unknown users. Extra. These are the demo implementation of our projects. As I told you before, this is the smart home security website where new user can register their faces through this website. If if the person is a known user, it automatically shows their faces and etc. If not, the person is an unknown user, it automatically uh, tells the user is an unknown user, or if they have a mask or any spectacles, it automatically detects they having the wear the mask and they have wear the mask, etc. If a known user uh, gets near to the door, it automatically detects it's an a person is an registered and the space detect is automatically enabled, so we can able to open the door and get into a house. As I told you before, the alert system is here. If an unknown user tries really captures their face, it's all doing in a real time session. It's not any delay or anything else. Uh, as you see here is an example sample picture that a person without an identification attempting to step into our houses. It automatically captures our faces and sending to a mail. Yeah, this is a result discussions. As I told you before, CNN has an better accuracy here than uh, accuracy formulas. As I told you that compared to all other algorithms that CNN have an very good percentages. So that why we have implemented it in here. In a conclusion, the best way we could protect our house from an unknown person is to keep ourselves aware of modern technology that could um, assist ourselves and able to protect in all other aspects. Having a smart door with a locked with a digital keys and then physical key is not a good option. I suggest that having a real-time technology that notify us real time would be a better option. The future looks that we have did despite recent advancements, facial recognition technology still faces challenges. Of course, it does because there are many factors that affects these projects. Maybe an lighting and then hacking, and these all could cause then this project could go failure. But none other that it be a good successful one. These are the references, and thank you all. Any queries, ma'am?
Hello.
Yeah, ma'am.
Actually, again, the same thing I have told in previous slides also. They have just done the survey. I think you have done the same thing. But I think the topic, whatever you have chosen, it was very nice. And even you were able to do some implementation on that, but you have not.
Thank you, ma'am.
So try to do that in your next paper. But I think the smart home, so many things have been already done on this smart home. But whatever you are choosing, the
Okay.
concept is very good, but try to implement.
Okay, ma'am. Thank you, ma'am.
Okay.
So thank you so much for the presentation. And now we'll move forward to our next presenter. And I would like to invite Sharmila Balan to present her paper on the title, Analyzing the Factor Influencing Post-COVID-19 Experience Through User-Generated Content, Luxury Hotel in India. So dear presenter, you may please start with your presentation now.
Yes, let me share the screen. Greetings, ma'am. Can you hear me? Yes, I am audible, I think so. Greetings all. I am Shamila Balat, a research scholar, and my co-author, Dr. Sangeeta Gunashekar, Associate Professor. And our study is on analyzing the factors influencing the post-COVID-19 experience through user-generated content, luxury hotels in India. Let me first start the introduction with COVID-19, which has created an impact in all the sectors, including service sectors, resulted in new service operation models to reduce the human contact. Hospitality industry is no exception, where the direct human contact is the main player. This has been adversely disrupted, drastic revenue decline. The next details let me say about customers' expectations. Post-COVID changed the customers' expectations in hospitality industry. The manager needs to focus on the changing experience expectations of the customer. To study the customer's expectations, user-generated content is the key source, which unfiltered information from the customers about the experience of the service. This is the only online review for the particular place by the customer. Then the research graph is about a reflection on India, which is rapidly expanding tourist destinations and will soon be in the list of top 10 leisure travel destinations in the forthcoming years. Only few literature is there when compared to the majority of the new location that have been researched during post-COVID. Post-COVID saw the sparse in literature and needs to be reviewed in as a customer's expectations and needs have changed in the aftermath of the pandemic. So the objective is about to analyze the factors impacting the customer satisfaction for the hotel industry related to Goa in post-pandemic period. The next is methodology. For identifying the factors, it involves three processes. The first is about input stage, that is the user-generated content, where scrapped data from the TripAdvisor, which is one of the most trusted travel website, with an online review used by tourists all over the world. Here I choose the Goa, which is a major tourist city of India, where 64,492 hotels consist of 110 luxury hotels. Out of this, I have scrapped user-generated content from 4 luxury hotels, which consist of 12,054 text reviews, which is the unstructured data. Next stage is a pre-processing stage, which converts the unstructured data into structured data using pre-processing process. The pre-processing process consists of accompanies 4 process, that is word tokenization, remove stop words and remove special characters and lematizations. The most common words. Word tokenization is about splitting the words, each word into individual tokens. The next is removing stop words. The more common words in the text data, like objective data, they are more common in the data. Example, he, have, and, etc. The next is removing special characters. Example, emojis, notations, and ASCII values. These characters may be in the text data. The next is lemmatizations. That is bringing back to the word into original meaning of the word. That is like a base word. And the one more feature of this process is to reduce the misunderstanding of the word can be like working and work. These are same words, but it can occupy the two different tokens. So to reduce this, we are using these process. And the next final stage is analysis. Leximancer opinion meaning software has work frequency calculations and co-occurrence of words, sentiment of word options to calculate theme. These are the list of positive themes for the data hospitality. Hospitality, experience, beach, room. And for the negative themes, service, help desk, property, stay, room. These are the negative things. And the next is the result. This is the conceptual map of positive reviews and negative reviews, which is formed based on the connectivity of the concept. The concept or like a gray node, that is the primary concept. Just only this shows the primary concept. To form a large bubbles, these primary concepts are grouped together to form a large bubbles. The theme and the positions of the small node around the bubble, their distance from other node denotes the semantic strength. The node size denotes the degree of the connectivity with the other concept. Then the other thing is that red and yellow are the warm colors, have more significant, a more significant theme in user-generated content. For positive review, hospitality and experience has more significant theme in user-generated content. For negative review, service, help desk, and property has more significant theme in user-generated content. The other colors like green, blue, purple are the cool colors, which are less significant in the user-generated content. The next is positive theme. Now I'm talking about the positive themes. There are total 9,182 positive reviews. Only 39 primary concepts were grouped to form 4 themes. Hospitality theme appeared 12,054 times in positive reviews with the sum of the primary concept of housekeeping, care, and team, care team and the manager. The next experience appears 8,308 times with the primary concept of comfortable, family, and holiday. Example, positive review from the customers given. Next, the negative theme. Out of 2,873 negative reviews, 47 concepts were extracted, were grouped to form 4 themes. Most dominant themes were selected in this. The service themes appeared to be 2,210 times in negative review with the sum of the primary concepts of clean, quality, and need. The next is help desk appears 2,161 times with the primary concept of booking, check-in, and private. The next theme is property appeared 1,892 times with the primary concept of family, people, and beach. And here the negative reviews is attached. And the next is conclusion. In this conclusion, I'm saying we have analyzed to understand the factor that leads to satisfactions among the customers of luxury hotels in Goa. This study find out the 7 attributes that played a major role in the positive review of sentiments of the review. That is, the hospitality seemed to have most significant impact on increasing the customer satisfactions. Among the themes identified from the negative sentiment, content analysis, customers seems to expect a clean room with a good and immediate response from the desk. Identifying these factors that influence customers' experience, health manager may make better decisions and create a system that are more effective in allocating the scarce resource of the firm to most important factors. And my limitation is This study is only focusing on sentiment analysis, excluded other text analysis methods. So the next is limitation is sample luxury hotels from one city in India is selected. So further research needs to focus on these dimensions. And my references. Thank you, ma'am. Any queries?
Yes, Sharmila, I think the task, whatever you have done, it was better than the previous papers. But still after that, I think you have to just represent some comparison table also. So I think after post COVID-19, there are so many topics, there are so many areas on which the students are working, and but I think so. If the some paper, the already implementation has been done by so many authors. If you compare your task with another one, I think it would be more better for your research.
Sure, ma'am.
Okay, okay,
Thank you, ma'am.
okay, welcome.
Thank you so much for the presentation. And now
Thank you.
moving further to our next presenter. Yeah, I would like to invite Pemadi Leela Venkat to please present his paper on the title Comparative Study on Text to Image Synthesis Using GNS. So dear presenter, you may please start with your presentation.
Thank you, ma'am, presenting me. So, ma'am, am I audible, ma'am? Hello.
Yes.
Yeah, thank you. Good evening to everyone. Our paper is about we have compared to three latest technologies, three latest GANs, generative adversarial networks, GANs which basically focusing on based on text they generate an image. Based on the given text description, they will generate an image. So we have reviewed three GANs, CI GAN, DI GAN, and cycle GAN. Before going to the text to image synthesis GANs, I will give a basic introduction about what are GANs. GANs, like the purpose of the GAN is we have some domains where there is only less knowledge, like there is no lot of data to make a model on that. In that cases, we have the technique called data augmentation. In the data augmentation, the data is artificially created based on the samples. So GANs are the most promising model of the data augmentation techniques. GANs are called generative adversarial networks. Basically GANs are composed of two models: generative model and discriminative model. Generative model which generates image based on by getting a random noise. By random noise, it generates image. And discriminative model, which like discriminate, it classifies the real image from fake image. Like it classifies which image is created by generative model and which image is the real one. So this is the basic architecture of GAN. Here we can see generative generative model takes n dimension. N dimension is nothing but a random noise, random vector, random numbers. It will take input as that, and it generates a fake image based on the random numbers. And for discriminator, we give input real image and fake image. Discriminator, like it classifies. If discriminator successfully classifies, if the value is above 0.5, then it has successfully classified it. So generator has failed to create a realistic fake image. So then optimization applies to generative model. If discriminator does not able to discriminate the fake image created by the generative model, then optimization is applied to discriminative model. So this is the basic architecture of GAN. So in the same way, GAN, this is the text to image based GANs, where for generative model, along with the random noise, we will give text features like blackboard with white belly, red eyes, LX. Like we will give characteristics or attributes for the requirements. What are the requirements of the image or bird? Then generative model use those text features to generate the model. So this is the like basic architecture of text to image conversion GANs. So our first paper is cycle consistent inverse GAN, and here the specialty of this cycle consistent inverse GAN is it not only generates the image based on text, but also modifies the image based on the text. Like here, how they have achieved this means first they will take the what we call as latent representations, like matrix numerical representation of the image, and they will play with this numerical. We will represent them as latent space representation of the image. So, and also we will take the representation of the text. By using these, they have some. They will combine these both, and they will call it as latent space alignment. In that latent space alignment, they will give the text encoder text features, by which they can generate the image. And the second paper is about dynamic aware GANs. So dynamic aware GANs is like they mainly focus on they mainly focus on the aspects like colors. Bird color eye is red, bird legs are yellow, bird's belly is white. So these accepts like they main focus on these major attributes and aspects of the text. So it introduced two new architectures in it: accept our local refinement and attended global refinement. This global refinement model, see first they will classify the text into three levels: sentence level, word level, and accept level. So these word level and sentence level are used for initial generation of image and giving the total structure of the image. First they will generate a rough total a rough image based on these sentence level and word level, and then they come to accept level text features, and based on those accept level features they will refine the generated image. So this is the DA again. And our third paper is about cycle GAN with BERT. Here the cycle GAN with BERT means these cycle GAN means they used the architecture from the cycle GAN, and they have used two: attention GAN and BERT model. And BERT model is a pre-trained language model. BERT is purely language model. It gives better text feature extractions. So from BERT model, they give the they take the text features, and attention generative model use those text features to generate the image. So final comparisons for these three models here. We can see the main components of first CI GAN are inversion GAN and latent space alignment, and DI GAN has two main components: accept our local refinement and attended global refinement. And in last we have as I said, attention GAN and cycle and BERT model are the main components. And in applications, it not only generates images but also manipulates the image using text. And for DA again, it generates image mainly focusing on the aspects of the image, and CycleGAN, it generates realistic images because it is getting more text features from the BERT model. So these are the loss functions and data sets. We can see these three models have worked upon one common data set called Cube 200 dataset. Cube 200 dataset consists of 11,000 different kind of barred images, with each image containing 10 captions. For each image, it contains 10 captions, 10 text descriptions of those images. So in final result, we have inspection scores. Inspection scores indicates like how well the model is generating, how realistic are the images, those images are. So we found that CycleGAN with BERT has highest inspection score with 5.92. So in sorry, in conclusion, we expecting that CycleGAN with BERT it has performed more than this, because CycleGAN with BERT has BERT model. BERT model is purely language based model. It giving more text feature text features, which make the model to create a more realistic images. Thank you, ma'am. And there are any remarks?
Yes, thanks, Leela. I think you have done the comparison between the different text to image conversation. We can say that the conversion, and you are
Yes, ma'am.
saying that the BERT model is best as per your consideration or as per your survey, whatever you have done. But can you
Yes,
tell
ma'am.
me which kind of images you can generate through text? Like if we are talking about the scene, live scene, and we have just created the text for that, can you generate these kind of images also?
Live scene, ma'am, just give me the description of the like one example description of. Can you
Suppose I
give?
am talking about one scenery or the hilly area, and whatever things are there in the hilly places, like the valleys and the trees like that, and the road just like that. If we are
Yes,
just
ma'am.
giving the description on that, so are you able to generate the complete picture of that scenery for which
Yes, ma'am. Yes, ma'am. Yes,
the
ma'am. They will.
description is done?
Based on the description, they will generate, ma'am. But the most accurate will be the one with the BERT model, because BERT is giving more text features to it. So they will generate one. They will generate based on the description.
Okay, what is the future scope of that?
Future scope, ma'am. This is generating the images like. There are different models, not only these three. There are multiple models, ma'am. Based on the text, they will generate the images. So but in our review, we have taken these three papers because these are very recently published papers, and BERT model is giving more accurate. So we are proposing that using the BERT model as a text extractor will give more strength to the generative images.
Okay. Okay, thank you.
Thank you.
Yeah, thank you for the presentation. And now we'll move further to our next presenter. And I would like to invite Divya Jyoti Morabat to present her paper on the title Multi-Level Association-Based 3D Multiple Object Tracking Framework for Self-Driving Cars. So,
Hello.
dear author, you may please start with your presentation.
Yeah, can you hear me?
Yes, we can hear you.
Can see my screen, right?
Yes.
Yeah. Good afternoon, everyone. I'm Divya Jyoti Morabat from Keli Technological University, Hubli, Karnataka. Currently, I'm pursuing electronics and communication in bachelor's. And the research work which I have done is multi-level association based 3D multiple object tracking framework for self-driving cars. This is the agenda for today's presentation. To start with, what is multi-object tracking? The process of tracking multiple objects simultaneously in a frame, it is called multi-object tracking. So the main goal is to track several objects and estimate their present states, such as like their position, their size, and velocities. And the application of this is very huge in autonomous driving and even audio visual object tracking in security surveillance and etc. And the second part of our research work is the integration of different sensors. The sensors are camera and lidar sensor. Here it is very effective, especially in case of autonomous cars, because it enables the detection of objects both close and far distance. So usually the 3D mod focus on tracking by detection algorithm. That is nothing but first it will locate the object, and depending on the result of that object detection, the trajectory of that object is computed. So the main motivation of multi-object tracking is to recognize and localize of all the known objects in a scene. For example, in order for a car to decide what to do further, like to accelerate or to turn or to apply brake, it needs to know where the objects are present around the car, and even what kind of object those are, big or small. So to know this, the multi-object tracking is the main thing. And by coming to the sensor fusion, what is the importance of sensor fusion? Sensor fusion, here we are using both camera and lidar. So camera can be detect far objects, whereas lidar, it is very difficult for lidar to capture far objects. So by fusing, we can overcome this issue. So overall, the motivation of using 3D mod, it depends on, it is very diverse. So the objectives of our research is, first thing, we have proposed a simple camera lidar fusion, which is performed through coordinate transformation, and then multiple association technique, multi-level association technique, that is nothing but that which efficiently merges 2D and also 3D trajectories. The main reason for this step is to fully utilize the properties of camera and lidar. And lastly, the extended Kalman filter is implemented to evaluate the condition of 3D trajectories. So this is the literature survey. The the like when we surveyed about the multiple object tracking, there were many 2D mod and 3D mod. The main thing what we observed here is 2D mod has some merits and demerits, and even 3D mod. But when we see fusion based mod, it actually solves all problems of a perception in an vehicle. So this is the literature survey which we have done. And the data set that we have included is the Kitty object tracking evaluation data set, which consists of 21 training sequence and 29 testing sequence of camera and both uh, lidar. Yeah, this is the main system architecture of our research project, which consists of five different levels. That is, first thing is sensor data. Sensor data is nothing but the input what we are giving, that consists of both lidar and camera data. And then object detection. Object detection, here we are doing a late fusion. That is, first we'll be detecting objects of both in 2D domain and 3D domain separately. Here lidar data object detection is carried out through point RCNN detection, whereas camera data, it is detected through RRC detection. After this, we'll be getting two bounding boxes. Those two bounding boxes will send to the data fusion. Data fusion is done through coordinate transformation and projection. That will be explained further. And then after this, multi-level association, which consists of three level of association, and then we'll finally will getting a 3D bonding box. I'll explain it further. So first, as I said, the camera and lidar is given individually. We have used Kitty object tracking evaluation dataset. Object detection, as I said, we are using camera images uses 2D detector, which is RRC recurrent rolling convolution, whereas lidar dataset uses 3D detector called point RCNN. Yeah. And after this, yeah, you can see here, once the both detectors results are obtained, the data fusion occurs. You can see here, right? D2D is a 2D domain, that is X and Y are the center coordinates and WH is the width and height. Whereas 3D, X, Y, Z, which consists of in 3D domain, these are the center coordinates, width, height, length, and heading angle. After these two type of bounding box, that is D2D and D3D, the that is the data fusion occurs. through coordinate transformation. Coordinate transformation is nothing but the 3D bonding box is projected onto the image domain. Yeah, that is D3D is projected onto D2D. The result which we get is the another 2D bonding box that is denoted by D2D 3D. The next step is the intersection of union between D2D 3D which we have obtained and the original D2D. When we calculate this, we'll be getting some result. That result is compared with some threshold. The threshold, if it is greater than threshold, then the fusion is complete and it is denoted by D2D 3D fused. And if it is less, then the objects in the image domain are represented at D2D only, and objects in the LiDAR domain are represented as D3D only. After this, multi-level association. The multi-level association consists of 3 levels. This is done because to solve two main problems, that is ID switching and even false negatives and false positives due to the detections by missed detection by detector. So as I said, it consists of 3 levels. First, in the first level, we'll be giving both camera and LiDAR detected detections that are fused with the existing 3D trajectories. As you can see, D2D 3D fused plus 3D trajectories. We are using here a cost function which defines as the intersection of union of ith detection and jth trajectory. Here the formula represents that. So when we use this cost function, we produce 3 outputs, that is matched 3D trajectories, unmatched 3D trajectories, and unmatched 3D detection. The matched 3D trajectories, they are initialized as they are like confirmed. Then unmatched 3D trajectories are given to the next level of association, and the unmatched 3D detection, they are initialized as the new confirmed trajectories. As I said, the unmatched 3D trajectory is given to second level of association. These are associated with LiDAR only, that is D3D only, as we saw before. So after associating here, this also they are successfully associated, then these trajectories are updated. So next in level 3, that is nothing but the unmatched 3D trajectories are associated with trajectories in the image domain in the third stage. As we know, the image domain, the 3D trajectory is projected to image domain, then we'll be finding intersection of union between the 2D bonding box and the original 2D bonding box. Then once it is successfully done, then all the trajectories are confirmed as a new confirmed trajectories. Yeah, while coming to evaluation matrix, we have considered 2 evaluation matrix, that is clear and HOTA. Clear consists of 3 main sub components, that is ID switch.
Divyajyoti, can you just conclude your presentation? I think you have already taken so much time.
Yeah, sure. This is the result which we have got. And if you want to visualize the result, here we can see the 3D bonding box of each object. We have considered car as an object. So you can see here. If you want to see the like consecutive frames, in a consecutive frames 3D bonding box, we can see here. So this is what the final results look like. Conclusion, as I said, it proposes a camera data fusion based 3D mod in which 3D bonding box of each object is created. These are some references. Yeah, thank you.
Yes. Divyajyoti, just tell me how many references or how many papers you have read before going to start this. Hello? Hello? Am I audible?
Yes, ma'am, you are audible.
Okay. I think Divyajyoti is not giving any answer.
Hello.
Hello, Divya.
Yeah, am I
Divyajyoti, are
audible?
you there?
Yeah.
Divyajyoti, just tell me how many papers you have read before just going to start this work.
Yeah, like almost around 20 papers, like for 10 papers at least I've read and I've gone through thoroughly. And remaining 10 papers, I just saw their input and their methodology and they just the results which are related to that.
But I think you have implemented this task.
Yeah, I have implemented.
But if you have implemented, I think 20 papers are not sufficient to start any event. First, you have to make a proper survey. How many research have been done for this area? And I am just saying these all I am just saying because of that you have not shown any comparison between your result and the previous deficiency, so that you can prove the your result is better than the previous.
Yeah, that's what in literature survey, the 2D mod and 3D mod, which I said, right? There are many papers which are based on 2D, and there are many papers which are based on 3D. So the research here is also fusion based, and in like during fusion, there are many kind of fusions, late fusion, early fusion. So coming up with one thing itself was for me like good progress, and I even thought thinking of implementing in custom data set, and I want to implement that.
Okay, but rest I think your implementation is very good, and I am even very impressed by your task. Thank you, and keep it up with your work.
Yeah. Thank you so much.
Very
Thank you for the presentation. And it's a request to the remaining participants that please conclude your presentation within the given time frame. And now moving forward to our next presenter. I would like to invite Kanika Bhalla to present her paper on the title Optimization in Fuzzy Clustering, a Review. Dear author, you may please start with your presentation.
Yeah. Hi, good evening, everyone. I hope I'm audible.
Yes, you're audible.
Okay. Is my screen visible?
Yes.
Yeah. So the topic of my presentation today is optimization in fuzzy clustering, a review. Basically, I've written a review paper to review all the fuzzy clustering algorithms. And the flow of the presentation goes like this. I'll be first taking up the introduction, then various fuzzy C-means algorithms, then the literature review that I have done, then bibliometric analysis, and then I'll conclude my presentation. So let me start by explaining the term clustering. It is basically an unsupervised data mining technique wherein the elements within the same group are highly similar, but they're different from other elements. And it can be categorized as into two types. One is the hard clustering and other is the soft clustering. So I'll be focusing mainly on this soft clustering part because the fuzzy C-means comes under the soft clustering. So this soft clustering is wherein the data elements share the membership in more than one group. So in this paper, I've reviewed FCM, which is the fuzzy C-means, and its four variations, which are the IFCM, KFCM, KIFCM, and FCM itself. So I have reviewed the pros and cons of all the four algorithms. And after that, I have reviewed various papers in which I've taken basically those papers in which these fuzzy clustering algorithms have been hybridized with various meta-heuristic techniques, and also dealt with the problem why there was a need to basically hybridize these already so popular and so used algorithms with the meta-heuristic algorithms like the particle swarm optimization, this genetic algorithm, and fish swarm algorithm, and colony optimization algorithm, etc. I have in this particular paper, I have reviewed a total of 49 papers, and out of those, I have seen that 29 papers have been based on FCM and the optimization algorithms. 8 papers were based on KFCM with various meta-heuristic optimization algorithms. 8 papers were based on IFCM with optimization algorithm, and remaining papers were based on KIFCM with optimized algorithm, because this KIFCM is comparatively a new technique compared to the previous other techniques. So comparing all the 4 algorithms, FCM, KFCM, IFCM, and KIFCM, I'll say that FCM is basically the most popular algorithm, but it is not able to identify the outliers properly. Now, KFCM works well with the cluster which are of unequal sizes. IFCM uses the hesitation degree along with the membership function, and it is able to give good results for non-spherical separable data. And KIFCM uses the features of both IFCM and KFCM and improves their accuracy, and it is able to work well with the non-hyperspherically separable data and also the data that have the uneven densities. Then basically my papers start, in which I have reviewed various other papers that have hybridized, that have been hybridized with various meta-heuristic algorithms. Now, first of all, this is basically the gist of all the papers, that they have used the data set on fuzzy clustering algorithms. They have implemented various optimization algorithms like particle swarm optimization, the various nature-inspired algorithms, genetic algorithm, ant colony optimization algorithm, and they have resulted in various clusters, which which is the main thing, or the results that we get from these various fuzzy clustering algorithms. So to begin with, I have taken basically the 6 parameters into the account: the author and the year. Then I have taken the optimization techniques which have been used, like particle swarm optimization, you can see over here, the fish swarm optimization genetic algorithm, which optimization technique the authors have used. And then I have taken into account the observations that I have collected from that paper, then the number of citations, then the data sets that have been used, and whether the paper has been published in a journal or a conference. So as you can see that I have taken 29 papers with FCM. AFCM I have taken 8 papers with IFCM, and 4 papers with KIFCM. So after that, I have done the bibliometric analysis in the form that the number of papers that have been published in journals is higher than the number of papers that have been published in the conferences. And as you can see from this particular figure, then I have observed that the number of publications in the early 2000s was lesser as compared to the late 2000, basically after 2006. And then the third observation that I have made is the IRIS data set has been used the maximum number of by a maximum number of authors to prove their results. And in the conclusion, I have shown this particular thing, that I've reviewed these 4 algorithms that have been optimized by various meta-heuristic algorithms, and then done the bibliometric analysis on all the above mentioned parameters. Thank you with my presentation. Any questions you can ask me.
Yes. Kanika, actually, the comparison, I think today is the day and everybody have done the survey, like they are just doing the comparative survey, and you have done the same thing. And you just told me in your first slide that you have reviewed 49 papers. This is the good thing, whatever you have done. But the second thing is, have you analyzed which are the positive things from different papers you have collected? Like there are so many papers you have read, and how
Yes,
many
ma'am.
positive things the different authors have done, and
Yes.
what are the weak points they have not covered? Because I
Yes,
think
ma'am.
if you have done any survey, the survey is not completed until you have given any recommendation for that. But I think for today's presentation, I think nobody is presenting in that way where they have given any recommendation. Even you have not given any recommendation, because if you are just doing any survey, so survey will be completed only when we have recommended something, because we have analyzed it in a very better way, so that we are able to recommend something. Are you able to recommend something for your survey?
Ma'am, right now I'm not in a position to answer that thing, because I've not taken that point into account. But definitely I have taken your input. I'll definitely try and do and look perform my analysis on that particular perspective, where I will be able to recommend something.
Okay, Kanika, just try to do that also. I think only survey paper is completed when it is having the recommendation part. part also.
Sure, ma'am. Sure. Thank you so much for your inputs, ma'am. Thank you so much.
Okay.
So thank you so much for the presentation. And now we'll move forward to our next presenter. And I would like to invite Raghav Dubey to present his paper on the title Pathfinding Visualizer, a survey of the state of art. So dear presenter, you may please start with your presentation.
Hello, I'm audible.
Yes, you're audible.
Is the presentation visible?
Yes.
Okay. So, hello everyone. I'm Raghav Dubey, the presenter for this presentation, and my co-presenter is Amuk Joshi. The topic for this presentation is Pathfinding Visualizer, a survey of the state of the art. Let's move ahead and take a look at the flow of the presentation. Firstly, we'll introduce to the topic. Pathfinding algorithms are crucial for the technological applications, finding the shortest or most efficient path between 2 points. Dijkstra's algorithm is one lone example, but A-star algorithm offers its own different strengths and weaknesses. A pathfinding visualizer is an interactive tool for understanding these algorithms, enabling comprehensive and intuitive learning. The study purpose is to design and develop an intuitive, interactive, and user-friendly pathfinding visualizer to provide a valuable resource for learning about pathfinding algorithms. Once again, we will cover all these topics later in the presentation with examples and analysis of the visualizer. Let's move to the literature review. So we're going to understand about the overview of the existing pathfinding visualizers. So there are several existing pathfinding visualizers available, ranging from simple static visualizations to complex interactive tools. Some of the key features and capabilities of existing pathfinding visualizers include visual representation of the environment, user-friendly interfaces, implementation of a variety of algorithms, such as best first search, depth first search, Dijkstra's algorithm, and A-star algorithm. Option to customize and adjust various parameters, ability to compare the results of different pathfinding algorithms, and to evaluate the performance in real time, and integration with educational material and resources. Now I would like my co-presenter Amuk Joshi to present the topic of the design of the pathfinding visualizer.
Thank you, Raghav. Am I audible?
Yes.
Yeah, so hello, my name is Amok Joshi, and now we'll see about the design of the pathfinding visualizer. The pathfinding visualizer has a user-friendly interface with 2 frames. The left frame has 3 drop-down menus for selecting maze types, while the right frame displays the real-time visualization. The interface also includes sliders to adjust wall density and visualization speed. Now we'll see about the types of mazes and algorithms used. In the left figure, we can clearly see the types of mazes. Here we can choose an option from the 3 options in the choose and configure the wall density. We can click on the build maze button to build the maze accordingly. In the right image, the algorithms are displayed. The users are presented with 4 different algorithms to choose from. The choice of algorithm is dependent on user for the desired application. Here we can clearly observe the variation in wall density intensities. The first image that is on the left of your screen depicts the default value. The second image shows the maximum value, and the third image represents the minimum value. The intensity can be adjusted by using the wall intensity slider, which will be further explained. Now we'll see about the mazes. The left figure shows a circular maze that demonstrates the capabilities of various algorithms useful for both academic study and practical applications in fields like gaming. The right figure presents a carved out maze idea for pathfinding, indicating the time needed for algorithms to find a path from source to destination. These 3 mazes types help users understand algorithm nature and select the most suitable one for a specific problem. Let us see about the implementation details. The visualizer was built using Python due to its popularity, simplicity, and versatility in various domains. Multiple libraries, including custom Tkinter and Tkinter, were utilized, and the development was done using JetBrains PyCharm IDE. Buttons were used as the grid layout, and custom ticketer was used to create the main visualizer layout and the learn page. If an algorithm cannot find a solution, a message will appear saying there is no solution, which is a rare occurrence. The use of Python allows developers to focus on problem solving, and the visualizer could be developed using other programming languages as well. Now I'll hand over to Rao.
So let's move on to the results. So this section provides an overview of the workings of the algorithms used in the visualizer. We will be discussing the operation of these algorithms as they generate the path from the source node to the destination node. The path is depicted in yellow color, as you can see. The blue color, ranging from light to dark, represents the area explored by the algorithms or the estimations made to find the shortest path. We are going to learn about BFS, that is breadth first search, and DFS, depth first search, in brief. BFS and DFS are popular graph traversal algorithms. BFS visits vertices in order of their distance from the root node, useful for finding the shortest path. DFS explores as far as possible before backtracking, useful for solving large spaces and problems which involve a large branching factor. Both algorithms implementation can be seen in this slide. So basically, we are making a base for focusing on BFS and DFS algorithms for understanding more complex A-star and Dijkstra algorithms. So now we'll see the implementation of Dijkstra's algorithm and A-star algorithm on default one densities. These are generated on random walls. So Dijkstra's algorithm finds the shortest path between source vertex to all the vertices by selecting the neighboring vertex with the smallest tentative distance and updating its neighbors until the destination is reached or all reachable vertices have been visited. Let's move towards the complexities. So these are the formulas to find the cost from the starting node to the end node, and we can refer to these formulas to find the actual path. So time complexity for Dijkstra with barriers. As you can see here, there are black barriers. So the algorithm has to skip all these black barriers to find the shortest path. So the time complexity can be given as big O of v plus e log v, and the space complexity can be given as big O of v plus e, where the v is number of nodes and e is the number of edges in the graphs. With barriers, the number of edges increases, resulting in a higher time and space complexity. Next, we'll move to the A-star algorithm. So this is the formula to calculate the shortest path between the two nodes by using A-star algorithm. Also, here we are using Manhattan distance. Euclidean distance can also be used, but for sake of understanding, we are using Manhattan distance. So in this section, we have thoroughly discussed the 4 algorithms in brief and their pathfinding capabilities. As seen, A-star and Dijkstra algorithm provide optimal answers due to their heuristic approach in the case of A-star and greedy approach in the case of Dijkstra. However, Dijkstra cannot provide an optimal solution for negative weights as it was designed for positive weights. On the other hand, BFS and DFS are just for reference and easy to understand algorithms that serve a solid foundation for more complex A-star and Dijkstra algorithm. To summarize, let's take a brief look at how the A-star and Dijkstra algorithms solve circular and carved out mazes. So this is the time complexity with barriers for A-star algorithm. These are the implementations of BFS and DFS algorithms in circular maze, and these are the implementations for Dijkstra and A-star algorithm for the circular maze. So basically, in conclusion, it is important to understand these algorithms and their capabilities to effectively solve complex pathfinding problems. This guide is a simple introduction to these algorithms. A user can experiment with the visualizer to observe the different outputs and answers produced by these algorithms for various mazes. The pathfinding algorithm visualizer allows user to customize and add new algorithms by tweaking the code. This enhances the versatility of the tool and empowers user to expand their knowledge beyond the preset algorithms. Additionally, users can collaborate by sharing their modified algorithms to improve them. In the pathfinding visualizer, we have included an example where the algorithm is unable to find a path from the start node to the end node, despite traversing the graph using different algorithms. This example is added to show that there may be situations where a solution may not be possible due to the positioning of the barriers, nodes, or other factors in the graph. The Learn tab in the visualizer provides information on pathfinding algorithms, including their pros and cons and use cases. It includes examples and analysis of complexities for the better understanding and serves as a quick reference for users to revise and learn the theoretical concepts behind these algorithms. Now we'll move to the implementation or the demonstration of the project. So I would like to share the screen for the implementation. So here, as we can see, this is the visualizer itself. So let's take a closer look at the demonstration of the pathfinding visualizer. The visualizer has 3 drop-down menus. As you can see, this is the first one, this is the second one, and this is the third one. The visualizer has 3 drop-down menus to help users to customize their pathfinding experience. The first menu provides 3 different types of barriers that can be placed in a grid. These includes random walls, circular maze, and carved-out maze. We can choose any one options, and this will create barriers for us, or we can create our own barriers. For example, if I choose to make my own set of path or set of maze, what I can do is I can place a starting point and an ending point. I can click on these buttons, which provides kind of a dynamic UI, and then I can start search. This is a speed slider for searching the algorithm. So if I take the speed slider to the left side, it means that the speed is going to increase for the algorithm. And similarly, if I take it to the right side, the speed of the algorithm will be slowing down. So if I just take it to the left side, so it should be calculating this in a very fast speed. So as you can see, it has calculated a path for me, and this is the shortest path. It provides a very efficient answer because of its heuristic heuristic approach. And there are many other options as well. For example, if I create random walls, so this is an example of random walls. And again, I can change wall density. So the wall density slider works as like, if I take this wall intensity slider to the left side, it means that I'm applying minimum value like this. If I'm taking it to the right side, I can again set it to the maximum value like this. So you can clearly see a major difference between the two values. Again, I can also change the starting nodes and the ending nodes depending on how I want to find the answer. Next is the circular maze. So again, this is a random maze generated, and each time if I click on build maze, a different maze will be generated. So it helps users to find multiple outputs for this visualizer. So, and the last is carved out maze. So the carved out maze works as follows. Like, what it does is it creates a maze for you like this. So it is creating a maze and keeping the node for the starting points and the ending points, and it will find it will create a maze for us. I can also create a maze by myself, as I have shown before. And if I want to run an algorithm, I'll simply select an algorithm. So basically, I'm only going to show A-star algorithm and Dijkstra algorithm because the other two we have already shown. So I can click on start search, and it will find a path for me, as you can see. And this path is efficient. Also, I can click on random walls. I can build the maze. And for example, if I want to reset the entire grid, I can click on the reset button, and again I can create it. And again, I can click on the start search button so that we can get a very optimal answer. Next, we have Dijkstra's algorithm. So Dijkstra's algorithm follows a greedy approach, and it also gives a very approximate answer because of its greedy approach. So yeah, and we can also increase the speed or decrease the speed accordingly. So this is at the maximum speed or maximum computational value, and this is at the slowest speed. So basically, this allows users to take a note of all the different types of outputs that has been created by the visualizer. Next, we have the Learn tab that I have already shown in the presentation. So basically, I can also show you here as well. So the Learn tab is already shown in the presentation itself. So we'll move to the presentation. And we have already depicted how the Learn tab works over here. So we can learn about the algorithms and how the algorithms work. There are multiple UI options as well, which can be changed and tweaked according to the user. Next, we'll move to the discussion part. That is how the visualizer contributes to a better understanding of pathfinding algorithms. So visualizers aid in the teaching algorithms by simplifying complex concepts through visual representation. They promote accessible concepts, active engagement, and provide a valuable teaching tool with advancing technology for understanding and development of algorithms, ultimately enhancing the learning experience and advancing in the field of computer science. In the conclusion part, visualizers for pathfinding algorithms benefit for students and instructors, providing clean and intuitive views that enhance understanding and promote active learning. Instructors can use them to demonstrate key concepts and then contribute to the advancement of computer science. Future improvements will increase their effectiveness, including interactivity, algorithm comparison, and better performance. Lastly, we have future work. The pathfinding visualizers currently demonstrate Dijkstra, BFS, DFS, and A-star algorithms. But future work includes expanding the visualizer to include other search algorithms, integrating with real-world examples, and supporting multiple agents. Additionally, a mathematical model is being developed to provide a more rigorous approach to analyzing pathfinding algorithms and contribute to the development of more efficient and effective algorithms in the computer science and technology. We are excited to continue exploring the potential of these tools and contribute to the advancement of fields. Thank you for your attention, and we hope you found this presentation informative and engaging. Thank you very much.
Okay. Raghav, very good. You have done very good task.
Thank you.
I just want to ask a single question.
Yes,
Why
ma'am.
you have not used another algorithm like A-star algorithm?
Yes, ma'am. We can use multiple algorithms in by just tweaking the code. Multiple like Floyd-Warshall algorithm can be used, and multiple variations for A-star algorithm and Dijkstra algorithm can be used as well by tweaking the code. It is up to the user, but
Even-
these are just generalized algorithms that are being given to the user so that they can tweak the code themselves to add multiple algorithms. So the basic things are provided to them.
Okay. No doubt. Whatever you have done, it was really very nice.
Thank you.
I was just little bit confused why you have not used AO-star. Actually, it is very good algorithm. Even we read in the artificial intelligence subject.
Yes,
It's okay. In your future scope, you can just start working on that algorithm also.
Sure, ma'am.
Keep it up.
Thank you, ma'am. Thank you very much.
Okay.
Thank you so much for the presentation. And now moving forward to our next presenter, I would like to invite Rajesh Saturi to please present his paper on the title Segmentation of Brain Tumor Images Using Morphological Reconstruction. So dear presenter, you may please start with your presentation.
Rajesh, are you there? Hello.
Yeah, I think
Rajesh
he has
has-
not joined the meeting.
Okay. Samang Gupta next.
Yeah, so we will move forward to our next presenter. Samang Gupta to present his paper on the title Sentiment Analysis of YouTube Comment Section in Indian News Channels. Dear presenter, you may please start with your presentation.
Hi, am I audible?
Yes, you are audible.
Yeah, so hi, my name is Sama Gupta and I'll be presenting on the topic sentiment analysis of YouTube comment section in Indian news channels. So we know that YouTube is a video sharing platform and the most popular video sharing platform with over 122 million active users daily. And due to its popularity, many news channels, various Indian news channels upload their news clippings on YouTube since they receive thousands of views and likes and comments every day. So what we did in this project was that we took the comments of Indian news channels, we selected some news channels, and then we took comments during the 2022 T20 World Cup, and we tried to analyze the sentiment of those comments so that we can know how users, what are the sentiments and feelings of the users, opinion of the users during that World Cup. So we analyzed using two libraries, TextBlob and Vader, and using this sentiment analysis, we can understand public's reaction to sporting events and then try to gauge the sentiment of online conversations. So how we did that, this is the methodology that we took YouTube videos, we extracted the comments, then we pre-processed the data, and then finally we did sentiment measure. So for data collection, we selected few popular news channels and we entered their names, and then we took all the matches that happened against India. So they were all the opponents were Pakistan, Netherlands, South Africa, and so on. Then we used Selenium to extract the comment section of the relative news channels. We took the URL of those videos and extracted top comments from those videos. So we took a custom keyword like T20 World Cup 2022, India versus the opponent name and then the news channel name. And using this, we got 129 unique video URLs. And from that, we made a total data set of 1150 multilingual comments, which were in Hindi and English. So our data had 638 comments in English language and 512 comments in Hindi language. So we had to change the comments in Hindi to English. For that, we used Google Translation API. And when we got all the comments in English, we cleaned the data. So we removed any unwanted words or characters and special characters, some stop words and all that. After that, we used two libraries, TextBlob and Vader. Now, TextBlob, both are sentiment analysis libraries. Both of them give us a sentiment label, positive, negative, or neutral. TextBlob has three labels, which is TextBlob will either give us -1, 0, or 1. -1 being negative, 0 being neutral, and 1 being positive. So using TextBlob on our data, we got 519 positive comments, 100 negative, and 531 neutral. Then we applied Vader to that data. Vader is Valence Aware Dictionary and Sentiment Reasoner, and it is said to be better than TextBlob because it firstly takes in consideration. It has a full list of words that has been assigned the number, and a number can be positive. So if a word is like happy, it will have a positive number. If it's sad, it will have a negative number, and it will find all those words in our sentence and assign a total compound score. So Vader also takes in case if it's capitalized or not, or if emojis are used. So using Vader, we got 549 positive comments, 198 negative comments, and 403 neutral comments. So for finalizing both of them, we made a final sentiment analysis data like column in our data set, in which we combined both the sentiment analysis results, and we want to have as much like neutral comments as low as possible. So after combining, like we replaced TextBlob with Vader wherever it was neutral, and thus we got 607 positive comments, 216 negative, and 327 neutral comments. After that, we analyzed the comments based on different news channels and different 1 second. Just a second. So then we analyzed all the comments based on the countries and different news channels, and we saw that in the matches India won, we see that there were less negative comments, and in the matches India lost, there were more negative comments. So it increased from somewhat 14% to 21% where India lost. And further, we saw that in different news channels, the ratio was different. So based on the content they put out, the ratio of positive and negative comments are very different right now, because it depends on the video how they are portraying. Then in the end, we used named entity recognition, which helps us find out names of people in the comment section. And we found out that where there were more positive comments, there were names like Virat Kohli, and when in the negative comments, there were names like KL Rahul or Rohit Sharma. So here we can use named entity recognition to find which player is more liked by the audience and which player is more disliked by the audience. So graphically, we can see that, for example, India lost to, I think, South Africa and England. And in those comments, in England, 27% are negative. In South Africa, 21% are negative. But in the matches India won, the negative comments are 11% or 14% at max. And even in different news channels, it varies based on the channel, the ratio of the comments. So this graph shows that in positive comments, Kohli has more positive comments, and in negative, Rohit and Rahul, these names have more negative comments. So this was just a specific data on a specific topic. We chose this topic because we thought that it will have both more positive and negative comments, because it was a whole, like India lost and won. So there will be both sentiments, audience sentiments. And we used two libraries which are predefined. But if we have like if you have data which has some predefined sentiment to it, then we can use our own models on above that libraries. So the conclusion is that these results were mostly positive in nature, and this study will help not only in this case, but it will be beneficial in many financial and social causes, because analyzing YouTube comments can help many business and organizations track and measure their effectiveness or of their marketing techniques. So if any business posts a video of or an advertisement, they can use the sentiment analysis to find out how audience likes that video or dislikes that video. They can use named entity recognition to see what words are there with each sentiment being used, so they can plan their ads and marketing strategies accordingly. And this will help businesses as well. And like even YouTube can use this method to see hate speech detection. So if there is some video which has a lot of hate speech, they can analyze if the video is suitable for audience or not. So this paper was on a specific topic, but we can use the same methodology to understand user sentiments across different platforms, not just YouTube, even Instagram or Facebook or any social media comment section. So thank you. Any questions?
Yes, Samang. The topic was good actually. Whatever you have taken, but I think so. Sentiment analysis. Most of the people have done so many things on sentiment analysis, but I think you have taken the data set from the YouTube. I think this is a better. We can say that the difference between whatever you have chosen and earlier one implementation has been done. So can you compare it with previous result also, because the already sentiment analysis has been done with the YouTube channel. Have you shown any comparison between your result and the previous result?
No, ma'am, because I saw that I saw many research papers and there were predefined data sets on those sentiment analysis. So like I didn't take any data set of that was already existed. I took comments from I scraped comments from actual videos. So the main difference was that those were supervised learning data set because they had some label assigned to it if we find any data set on the internet. But mine was
Samank, it is
unsupervised.
very good
Yes.
that you are taking your own data, but the difference is how you can say that you are just getting the result in the better way, or how you can say that your results are accurate, because whatever research which is already been done by so many other authors, they have already done so many they have already get so many results for this data set. If first you try to compare with the previous data set, and after that if we can say that your model is good for that, it means then you can go with the another data set. But first you have to test that either your data either your model whatever you have prepared, it should be run in the correct way. Only then you can start with your own data.
Yeah, ma'am. So the difference in mine was that firstly, many people use if they're using TextBlob or Vader, they usually use one of them. But I used both so that both of them give some result and we can combine both of their results to get a better prediction out of it. So others
No, it's okay. It's
usually,
okay.
yes, ma'am.
Just try to calculate the result with the previous data set,
Yeah,
whatever
sure.
mentioned in the Kaggle or somewhere else, and then just try to conclude it with your own data set, so that
Yeah,
you can compare. You can just tell your system is giving the correct result.
yeah, sure, ma'am.
Okay.
Yeah, thank you.
Okay. Welcome. Okay.
Thank you so much for the presentation. And with that, we have completed all our presentations for the session. And yeah, so now I sincerely thank all the presenters for their excellent presentation and contribution in the session, and all our participants for being a part of this international conference. I hope the session was informative enough for you all. We, on behalf of the whole team, thank you for your support during this version and the previous 6 versions of the conference. And we will be happy to have you in the 8th version in 2024. All the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. So the publication will be live within 6 months. So kindly cooperate with the team of ICTIS 2023. I would also like to thank our session chair for chairing the session. And here is a small token of appreciation on behalf of the team ICTIS and Global Knowledge Research Foundation and partners. So thank you so much for your valuable presence, ma'am. And yeah, so now I would request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.